the roaring 40s of the southern hemisphere, the windiest latitudes on the planet. Here, blowing largely unimpeded across the southern oceans, winds circle between the subtropic highs and subpolar lows. As these westerly air currents move over New Zealand's ranges, they're shaped into prevailing winds and weather patterns. On a direct west to east path, the lowest crossing of New Zealand, south of the volcanic plateau, occurs where the northern slopes of the Tararua's ranges descend towards the Manawatu Gorge. This area is not only the path of least resistance for the wind currents, it is also from coast to coast the catchment of New Zealand's most enterprising network company, Central Power.
Central Power is a regional electricity company based in Palmerston North. It covers an area running from Hamatangi in the west through to Akatea in the east and covers both a mix of urban and rural areas.
In 1992, Central Power decided to investigate the feasibility of wind energy. This was a time before the Asian economic crisis. The New Zealand dollar was moving ahead of other countries. Strong growth was forecast, and economic growth is powered by electricity. However, the hydro crisis of 1992, as New Zealand's hydro lakes fell to their lowest levels in recorded history, proved just how fragile this source of New Zealand's electricity could become. At the same time, the government started to reform the electricity market. The national grid operator, Transpower, was split from ECNZ, and a spot market opened for the purchase of electricity. If electricity was to be in short supply, there is only one direction the price would go. The decision in 1996 to form Tararua Windfarm and build a large wind farm within Central Power's catchment area would provide Central Power with a local generation capability. No longer would security of supply for Central Power's customers rely solely on the output of distant hydro and thermal stations. Only 11 kilometers from the major load center of Palmerston North, Central Power's investigations had researched a wind farm site and found a predicted performance potentially higher than any other wind farm reported in the world. Local support for a wind farm was also high, and resource consent for the project was granted in February 1996. From 5 tendering wind turbine manufacturers, Vestas was chosen in December 1997. To understand what makes the Tararuas potentially the world's best location for a wind farm site, first we must look at how much energy can be captured by one of the world's most advanced wind turbines, the Vestas V47 660 kilowatt. The V47 660 kilowatt is produced by Vestas Wind Systems, a Danish wind turbine manufacturer with 22% global wind turbine market share. The V47 startup speed is 4 meters per second, meaning it starts generating in a 14 kilometer per hour wind, a light breeze. At 8 meters per second or 28.8 kilometers per hour, a moderate breeze, the turbine is generating 240 kilowatts. Because wind energy increases at the cube of the wind speed, a rapid increase in energy with a positive power curve continues almost up to 10 meters per second, with 440 kilowatts being produced in a 36 kilometer per hour wind, a fresh breeze. Here the power curve flattens out and the V47 reaches its maximum output of 660 kilowatts in slightly more than 15 meters per second, 50 kilometers per hour, or a strong breeze. The V47 maintains this output of 660 kilowatts through strong winds, gales, until a storm-level wind exceeding 25 meters per second or 90 kilometers per hour causes the turbine to cease generating, preventing possible damage. Construction of the Tararua Windfarm began in March 1998 with the commencement of access roads and work on the tower foundations. Contractor's main seal used 4,000 cubic meters of concrete, equivalent to the concrete foundations of 160 homes, for the 48 tower foundations. This work is now hidden underground. Napier Steel Fabricators Eastbridge used 1,500 tons of steel in manufacturing the 40-meter-high towers. Assembled on-site in 2 sections, the first towers were erected in October 1998, just as the first turbines were beginning to arrive. The site is located on 700 hectares of private land. To capture the wind effectively, the turbines are located along 4.3 kilometers of the ridgeline. Coexisting with sheep and beef farming, the turbines occupy less than 1% of the land area. Towering over the farmland below, the turbines are supported on lattice towers to reduce their visual impact from a distance.
This site has the potential to be one of, if not the top, potentially one of the top 5 in the world, and existing capacity factors are of the order of in excess of, some of these turbines are achieving in excess of 60% capacity factor. So that would make them potentially some of the highest producers in the world.
To understand how much power a V47 660 kilowatt turbine will generate at the wind farm, consider that the V47 startup speed is 4 meters per second, and for 92% of the time, the wind speed's hourly mean at the site will exceed the speed. For 65% of the time, the wind speed at the site exceeds 8 meters per second, and each turbine will be generating in excess of 240 kilowatts. Then consider that for 25% of the time, the wind speed exceeds 14 meters per second, and each turbine's full 660 kilowatts is available, except when, for less than 1% of the time, the winds are above 25 meters per second and the turbines are feathered. This is called the wind speed distribution curve. Unlike hydro and thermal technologies, wind turbines are a highly modular approach to installing generation capacity. The resource consent for the wind farm allows for up to 103 turbines. Stage 1 of the project, to produce 31.7 megawatts, involved the construction of 48 turbines. The power produced from these turbines is equivalent to the total energy requirements of 15,000 homes.
The Tararua Windfarm is quite a big wind farm for us. It consists of 48 turbines. Though we have been working on bigger wind farms in China and the United States, this is amongst the big wind farms. I guess the wind has been the biggest hurdle in this project. We say around 12 meters per second is the maximum, but we've learned from this project to put it up in 15 meters per second.
As each turbine was completed, it was connected to the network and underwent testing and commissioning before becoming operational. The first turbine to feed electricity into Central Power's network began in a light breeze on the 20th of November 1998, with Denmark's Foreign Minister Niels Helvig Petersen officially setting the first rotor turning. The extensive electrical infrastructure for the project was built by Central Power's contracting subsidiary, Energy Connections. The output from each turbine is taken by underground cable to a substation and switching yard in the middle of the site. From there it's taken by overhead line to feed into the network. Construction periods for wind farms are relatively short. From when the first tower was lifted, the construction of all 48 towers, the lifting of nacelles and rotors, and cable laying took a total of 7 months. The workforce to achieve this ranged between 15 and 40 staff. These included a small number of skilled wind technicians from Vestas in Denmark. The Tararua Windfarm is unique in that it is probably the first large-scale wind farm built in the world without subsidies or incentives. The total cost of the project was $50 million. Of this, $15 million was spent with New Zealand contractors, as many as feasible from within the Manawatu and Tararua areas. Even before the wind farm was completed, with wind turbines generating, contractors were using this wind energy to complete the remaining turbines. Since the inception of the Tararua Wind Power Project, New Zealand's political climate has changed. Forecast growth disappeared into recession as the effects of the late 90s Asian crisis clouded New Zealand's economy. The New Zealand dollar fell sharply from its all-time highs, and in the generation game, the government decided to legislate to change the rules.
During the construction of the project, the government introduced some reforms to the electricity industry, which required companies to separate ownership of their competitive generation and retailing activities from their monopoly lines activities. Because Central Power is fundamentally a lines company, it took the decision to sell its generation activities.
As a result of the Electricity Industry Reform Act 1998, Central Power was forced to sell Tararua Wind Power. The new owner of the wind farm is Trust Power, a generation and retail company based in Tauranga.
We're going to see more and more a real interest and desire for green energy, and of course wind technology provides exactly that.
We can't look to the future with 2020 vision, but by the year 2020, the initial 48 turbines will be reaching the end of their economic lives. In each year of generation, they will have offset the release of 80,000 tons of greenhouse gases into New Zealand's clean, green atmosphere. Their lifespan will have eclipsed the life of the Maui gas field and the large generation stations fueled by it. As the winds change, they will point not only to the direction of the roaring 40s or the anabatic winds that blow off the plains below, but to a new future. A future of non-polluting, sustainable and renewable energy. A future of wind farms across New Zealand.
In the future, I would expect that the turbines will be even cheaper, producing more energy at a lower cost, and that will certainly offer opportunity for other people, hopefully in New Zealand and elsewhere, to be building other wind farms.
Two companies have seen this future, and they have made it visible.